class off. Okay, everybody, so we're taking some notes on the scientific method versus the engineering design cycle. Here are the key things to watch out for. Number one, similarities. What's similar? Number two, differences. But here, number three, this is the big crucial one, okay? Number three is the crucial one. How and why do we keep records? How do we keep records of what we're doing? That's really only the difference between messing around and doing science. You write it down. Okay? The only difference between messing around and science is you write it down. Because it's very powerful if you're keeping records, then you can be improving upon yourself, both science method and also engineering design process. We have already talked about the scientific process. Don't take these notes. Do not take these notes. This is just a review, right? It's the scientific process. You make an observation, you do some research, you form a hypothesis, you test that hypothesis with an experiment, draw conclusions, communicate results. We've seen this, right?
Yes.
We've been doing it this year, right? We've been practicing, we're going to be practicing all year. That's fine. Let's talk about it though. It's kind of like a loop or a cycle. Is it a one-way trip around the loop though? Do you just like do the hypothesis, make the test, boom, and you're done? Or are you constantly cycling and improving and cycling and improving? And it's an ongoing process, right? Because every time you have a test and you get some data, you come up with a theory, then you're going to make new observations about that theory and new hypotheses about that, and you'll develop new tests and you'll keep going around and around and around, and that's how we improve our understanding of the universe. Is with this process. That's very powerful. Engineering design process, this is the notes you want to take. Here's the engineering design cycle. It's over here on the wall also. On the wall it's called the engineering design process. On the board I'm calling it the engineering design cycle. Does it matter what you call it? No, I don't care. It's the same thing. Here's the general form though. You're going to ask a question or identify some sort of problem. So if you're an engineer, or if you're an engineer, you might notice a problem people are having. And so you got to start asking a question yourself, okay, but what is the problem? This is where you're also going to start to do some research. You'd be like, well, what have other people done to solve that problem? What's been tried already? That's a really crucial place to start. It feels like it's cheating, right? If you ask what people have already done. But it's one of the powerful things of the method because it builds on what's already out there. And so it's always getting better and better and better. You'll identify that problem. You'll figure out what are the constraints. Can I see a show of hands? Who's heard the word constraints before? Maybe PLTW last year? Lauren, what is a constraint? Do you know?
Like something that you have to work within.
Yeah, something you have to work within. A limitation, right? You got to figure out what those are as you're identifying your problem. Next, you'll imagine a solution, right? You'll just brainstorm some stuff. You'll make a plan. You'll brainstorm it, and then you'll pick the best idea, and you'll make a plan. As an engineer, when you're making your plan, you're like drawing diagrams, you're labeling things, you're starting to figure out what materials you need, and then we get to the fun part. Okay, 1, 2, 3. They've been really important, but the fun part, of course, is to create. You make a prototype. Do we know the word prototype?
Yes.
Yeah.
Kaden, what's a prototype?
It's like, it's not the real thing, but it's like your basic design.
Yeah, it's not the real one, but it's like the test model
Yeah.
they're going to do tests on. So you're going to create some kind of prototype, and then you're going to test that prototype out. You got to run it through tests. Try to break it, basically, and figure out what caused it to break so you can make it better. And that's where you'll be improving it. You'll make improvements on it, and then you go back and test that out. And so this little cycle of 4 to 5, and back to 4, and back to 5, and you're boom, 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 breaking it, fixing it, breaking it, fixing it, figuring out where the issues are and making it better and better and better is the power of the engineering design process. I'm going to give you a new word. Are you ready? It's an iterative design process. Everyone repeat after me. Iterative.
Iterative.
It's an iterative design process. Have you heard the word iteration?
Yeah.
It's maybe kind of a new word to some people. Iteration means like the version, the next version, and each version is a slight improvement on the next version. Have you seen computer programmers do this all the time? You've had like Windows 7, Windows 7.1, Windows 7.1.1.2 or whatever. You know, you've seen that in computer games? Yeah, each of those next versions is an iteration. And so the engineers, the computer engineers, are constantly trying to do little improvements and make it better and better and better. Does your first prototype have to be perfect?
No.
In fact, you guarantee that it's not going to be perfect, and that's fine. That's great. You just get something built, and then you start testing it and making improvements in that iterative design process. Okay, that's our engineering design process. So, is it a one-way trip around the circle, or is it ongoing, constantly bouncing around, ongoing process? What do you think?
Ongoing.
ongoing until your employer is like, we need to just like sell this stuff and get it to market. But until that time, you're like making improvements, making improvements, constantly bouncing around the process. Okay, let's talk about recording. The big thing I want to talk about is how do we take records? How do we keep good records? I've got some exemplary examples. This is the part of the lecture that I'm kind of proud of. I've got some examples on the board that we're going to flip through. You're going to talk with your neighbor and your partner about what you notice going on in those lab notebooks, okay? When you enter a science lab, a professional science lab, or a professional engineering lab, you're going to have a notebook. Like often, do you notice what kind of notebook this is? Is it a spiral one, or is it one of those like bound ones where it's like actually sewed together? Yeah, it's hard to rip pages out of those without noticing. You can always tell if a page is ripped out. So you can tell if your lab notebook got tampered with or if evidence has been falsified. It's actually like a legal thing in an engineering or a science lab. You will always have one of these at your bench, your workbench, or the experiment. Let's talk about what you notice. Just sort of how do they organize it, what are they doing with it? I know it's a little blurry, but that's actually fine. Talk to your neighbor right now, make a couple observations. What do you see? Go!
Yes, a lot of papers.
Let's focus on the Bible. Focus on the book, right? The book.
Numbers.
A lot of math.
I bet it gets like the main point about it.
It's a lot of variables.
It's a huge.
It's not, yeah, it's not like.
Let's bring it back and we'll start talking about what we notice. This is a lab notebook. They've got their experiments next to it, right? Looks like they're doing some sort of biology experiments here. And then they're recording stuff in this. Jackson, what do you notice here?
They kept like all the parts very organized.
It's very organized. Everything's neat and kind of has its place, right? Yeah, for sure. Oh, she's every day. Lauren, what do you notice?
There's a lot of writing, but it's not like paragraphs of writing. There's not.
Are you noticing white space? Yeah, they left a lot of blank space, right? Look, they've got like a little blurb, but then they skip lines. Lots of line skipping. Do you think that's a good idea when you're taking lab notes? Oh yeah, skip lines like it's going out of style. Leave room for yourself to come back later and to actually read this, because that white space will help you be able to do that. Kristen, what else do you notice?
It's like graph.
Oh yeah, they used graph paper. Do you have to use graph paper? No, but if you want to today, I have graph paper for you. It's in this. It's in the basket. Amber, what else do you notice?
There's lots of numbers.
I see numbers. Yeah, for sure. So they're taking data. They're collecting quantitative numbers data. Okay. Tyreek, what else do you notice?
It's really neat writing.
It's neat writing. Yeah, they've thought this. They've realized that somebody else is going to come back and read this, right? They might have to read it or somebody else. So it's like neatish writing. It's pretty good. I'm noticing. Check this out. They've got some sort of thing here, and they've got an arrow pointing to it with a clarification. That's big. They recognize that they might not remember what that means later, so they've given themselves a hint. Leave little clues for yourself later. I dig that. Lots of white space. Yeah, organized. I like it. You want to check out the next one? This is like world famous. This next one, one of the best in the world. You ready? You don't know who this is?
Albert.
Possibly smarter than Einstein.
Oh yeah, I know who it is. I forgot his name.
Some fella.
Give you a hint. We just took a test on his laws.
Newton.
This is Isaac Newton's actual lab notebook. This is a page of his lab notebook. Okay, what do you notice? Talk to your partner. What do you notice about his lab notebook? Go.
It seems like it's like out of order kind of. They're going diagonal.
He's doing long division.
Dang.
He's doing long division.
Amazing.
By hand. Yeah, so, okay, what do we notice here? Prince, what do you notice about Newton's bind?
Very complex.
It's complex, but what has he left? Has he left a lot of white space for us?
Yes.
Yeah, so we can still see it, right? Is his complexity kind of gridded and does it have an organization?
Yeah.
Yeah, totally, right? Dane, what else you notice?
There's a lot of numbers.
A lot of numbers, right? A lot of numbers. Kennedy, what do you notice?
He wrote like diagonal kind of.
Yeah, you want to know what he's doing here?
Yeah.
He's doing long division, you guys. He's doing the math out. Because when was Newton alive? Any ideas? 1600s. Something like 400 years ago. Yeah, electricity was not a thing. He was doing this with a quill and pen on like parchment. They did the math out. He's a math. I mean, he's probably one of the smartest people to alive. But hold on a second. Do you notice anything?
He crossed out numbers.
He messed up. One of the smartest people to ever live messed up on his math. And realized it, crossed it out, corrected it. Boom. That to me is like huge, because that's this little glimpse into like, okay, Newton's one of the smartest people that's ever existed, but he's just a dude. He's just some guy. Just a person struggling with math like all of us. He made a mistake. He just crossed it out and kept going.
Wait, so he's doing division with really big numbers?
Yeah. Ginormous numbers. Yeah. What else do we notice? Is it all numbers?
No.
Look, he's got some notes to himself, some word notes. Yeah. Okay, let's go to the next one. Another world famous.